Okay, so in this video, we're going to look at what the general term is. Some of you were having some trouble in Taylor's series with general term. So we're going to start with homework set number 6. I'm going to work a few problems from 6, 7, and 8, and hopefully we better understand it. So we need to know that when we're writing a Taylor series, it's the derivative over n factorial times x minus a to the n, where a is where it's centered about. So if we're looking at number 8 on homework set number 6, it gives us the derivative right here. Okay? So if I want to write the general term for that, it's simply going to be the derivative n minus 1 factorial over 2 the n over n factorial times x minus a. We're going x minus 1. Sorry, it's centered about 1. All to the n power. Okay? So, what I did in this problem is, you can leave it like this if you want to, but what I did is I canceled a factorial. So let's go through how to cancel a factorial. So, the smaller one out of these two factorials is n minus 1 factorial. So we're going to leave that one alone. And so this becomes n times n minus 1 factorial. Okay, remember a factorial is just you're multiplying by one term less. Okay, so the n minus 1's cancel. And that's how I arrived as my general term looking like this on that question. Okay, so that's pretty easy. Not too bad. You could have left it like this if you wanted to. It probably just makes your life more difficult if you're going to be plugging into it. That way, when you go to do your general term, it's super easy to take a derivative of it, okay, or an integral. Okay, we're just going to be integrating with respect to x, so we just add 1 to the exponent divided by the new exponent for this term. Okay, so let's look at. This is going to be number 7 on homework set. It would have helped if I kept them in order. I think it's number 7 on homework set 7. Okay, so let's look at this problem. Now, it says the series is given for natural log of 1 plus x, and your general term is right there. Okay, so it says write the first 4 non-zero terms in the general term for the Maclaurin series f. Okay, and f is given by this. So what we're going to do is we're going to keep this x on the outside. Okay, and we're just going to deal with this. So what is changing from here to here is x divided by 3. So all you're going to do is I'm going to leave, so this is number 7. I think it's homework set 7. Forgive me if it's not. You can go through and look at it. So what I'm going to do is I'm going to take this x over 3 and I'm going to substitute it everywhere there's an x up here. So I'm going to have a negative 1 to the n plus 1 times x over 3 to the n power all over n. Okay, and then I'm going to, I have to deal with this x on the outside. So when I deal with that x on the outside, this is x to the 1 power, right? So I'm going to leave this negative 1 to the n plus 1 alone. I'm going to split this as x to the n plus 1 because x to the n, and when I multiply exponents, I add them. And I'm going to take that 3 to the n and I'm going to put it to the bottom of the fraction. Okay? So that is what our general term looks like for that one. Okay? So use your knowledge of if it gives you the general term up here, look what's changing. So what's changing here is the x over 3. So I'm just substituting it. And a lot of these questions, that's how they operate. Okay? Let's look at this one. Number 8. Okay? It says let f of x be the natural log of 1 plus x cubed. Now it gives you the series for natural log of 1 plus x. So what's changing between here and here? Well, it's x cubed instead of x. So what I'm going to do is I'm going to go up here and I'm going to substitute an x cubed for x. Okay? So this is number 8. So my general term should be negative 1 to the n plus 1. And then I'm substituting x cubed right there. And I'm still dividing by n. Okay, so it's negative 1 to the n plus 1 times x to the 3n over n. So that's my general term for number 8. Okay, so those two are pretty similar in how we find the general term. Let's see. Let's look at this one. This is the tricky one. This is going to be number 9. Number 9 on homework set. I think the last homework set. Okay, so you have f of x is equal to 6 e to the negative x over 3. Now it says for part A, it says you want to find the first 4 non-zero terms in the general term for the Taylor series about x is equal to 0. Okay, so what I would do, and I didn't really have room to do this, so forgive me. So we're going to take our first few derivatives. Now watch how I do this. The 6 is going to stay in front, and when you take a derivative of e, it's e to the u du. So I'm going to multiply by negative 1/3. E to the negative x over 3. Now I'm going to take a derivative again. Okay, so when I take the derivative again, I get negative 1/3 squared. E to the negative x over 3. And when I take the third derivative, I get 6 times negative 1/3 cubed e to the negative x over 3. And then if we just go first 4 non-zero terms, so that's 4 terms right there. Okay, so if I was to look for the pattern, the 6 is staying constant, okay? The negative 1/3 power comes from, so this will be raised to the n power because this is n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3, okay? So we're gonna go by that terminology right there. So when we go to write a Taylor series, it's the derivative over n factorial times x minus a all to the n power. Okay, and if you don't remember that, then write it on your cheat sheet. Okay, so my derivative is 6 times negative 1/3 to the n power. Okay, and I'm plugging in a 0, right? So e to the 0 is 1, so that's not going to affect anything right there. Okay, and that's going to all be over n factorial. Okay, times x to the n power. And so all I'm going to do is split it up from there. So 6 to the negative 1 to the n power, x to the n. I'm going to split this 3 up and I'm going to put it on the bottom. You get something that looks like that. Ta-da, you're done. Okay, so that's how you get your general term, like I did it. So anytime like you start taking derivatives like this, yeah, we all know how to take a derivative, we all know how to plug in, but it's hard to see what the pattern's doing. So if you split it down like this, then you'll be in a little bit better shape. And I know we didn't have a lot of, face-to-face time with this stuff because it was one of the last things we learned. But that's how we look for the pattern. And that is probably the easiest way to do this, okay? Let's talk through this one real quick, even though I don't think it's going to be on, I don't think power series is going to be on your AP exam this year. Okay, so when we have a power series, it's x to the n. The series x to the n is equal to 1 over 1 minus x. Okay, so if we get it in a geometric series form, which is this, we would, so remember we stripped out the 2x first, and we have to get it into this form. So whatever's right here is raised to the n power when you put it into a series format. So whatever's like right here, you put it into a series format. So that's where I get negative x to the 2n. Okay. Now I'm going to distribute this n power out. So that's where I get the negative 1 to the n power. X to the 2n. Okay, that's pretty easy to go. Now I have an x on the outside, so that's where the plus 1 comes from, and I have a 2. Okay, so that's how you would get the general term for that power series. Okay, I don't think that's going to be on your AP test this year, but I could be wrong. So if you have any questions on specific questions after this, feel free to reach out. Let me know if you need any help. Thanks, and good luck.